In this video, I'm going to speak about how to perform eigenvalue analysis by using Microsoft Excel. As you know, Microsoft Excel is available on every desktop or laptop, and it's very common to use it for different purposes. Again, I review what we want to solve. This is the same problem as the previous videos, and the problem is when we come up in this section to set this determinant to 0, here it is not very difficult because it has only 2 degrees of freedoms and the matrix is 2 by 2. However, if you're dealing with some sort of problems with more degrees of freedoms like 10-story building or whatever it is in your coursework, you may come up with this fact that this is very much of a hassle if you manually want to solve this equation. That's why I'm going to show you how we can solve this with Excel, which means that in any case of matrix, it's very easy to use it to solve your problem. So we are going to talk about this matrix and how to solve this matrix in terms of setting the determinant equal to 0. If you take a look at this Excel, which is available on Moodle, there is a spreadsheet named by Excel, and these are the names. So they are really just names and they do not contribute to the calculations. It's just for reminding myself what are these values are. So I just enter the K matrix here in these 4 cells. And just to be more precise, I just linked them with the previous spreadsheet that I was formerly using with for my manual calculations. For example, this one is coming from a spreadsheet manually E2, which means here E2 is this number. So this is connected to this cell. If I change this cell, automatically this cell will be updated. So it's the advantage of Excel always. And when you put these numbers here, you can select these 4 cells all together, as you see. And you always have a box up here in the left hand side, and you can click on it and write a name like stiffness matrix. And it's usually something like, for example, if I grab these 4 cells, you will see it's I2. But if I click here and write a name, my own name will be the name of these 4. So I've done it and I've named it stiffness matrix. Here I put these values as my mass matrix, and I made it I named it mass matrix here. And here is lambda, which is actually the square omega. And let's set it to 0. I can always start from 0. And here, if you note here, what you really need to do is I can just delete this, and you can select these cells and go here to write your formula and write like this: stiffness matrix minus lambda multiplied by mass matrix. Stiffness matrix and mass matrix are these 2. Lambda is this one. And when I write this formula, Excel understands that what are these 3 parameters, because previously I've named them, right? When you write this formula here, hold your shift and control keys and press enter. If you do that, it will fill up all the cells with the formula that you have done based on these matrices. So if you do that, this means that it is calculating the k minus omega to m, and the result is here. In the case of omega is equal to 0, lambda is equal to 0. And here in this cell, I'm calculating the matrix determinant of, also, sorry, before that, after I filled in these cells, I named it aim, like aim or whatever, like objective function or whatever you like. So the name of these 4 cells are a matrix aim. And here I calculate, this is a function of Excel, mdeterm means matrix determinant, and mdeterm aim means determinant of this matrix. So exactly whatever I want. But the problem is that I want this determinant to be 0, not something very big like this one. This is really the determinant of this matrix as equal to 4.9 times 10 power 14. To find the corresponding lambda, which brings you to the 0 here, there is a very awesome tool in Excel. If you go to the data menu, and there is a forecast section here, what if analysis. If you open it, there is a goal seek. If you select goal seek, there are just 3 parameters you need to define. And it's very easy to understand what it is going to do. See, set cell, this one, enter. To value 0, I want this cell to be 0 by changing which cell? This cell, enter. So it means that please change this cell for me to come up with 0 here. Whatever relations are defined between these cells will be active during this process. So if I press OK, you can see it's going to calculate, and now this cell is not 0, it's 144 point something, and the determinant is 0. So I just copy this value and bring it here for the Excel, because here I'm comparing the T1 and T2, and as you know, T1 is, I just copied that value here. You should make a square because that's omega 2, I want omega, and then you need to calculate 2 times pi over omega. This is omega, and the result will be 0.4230, which is exactly like this one. And it means that, because it's obvious, because I'm working with the same stiffness and mass matrix as I was working with manual calculations, so they are really identical. So these two are really these two. And just take a look again at this sheet, because it only gave me one root of the equation, and for the other, it's really working like Newton-Raphson method in the math, if you remember. For example, I started with 0, and it's a kind of numerical iteration to find the right answer for the question. So it starts from 0, proceeds to the right and left to see what kind of solution can be found. If I repeat the process, what if analysis and goal seek, and sorry, again this time I start from something like 1,000 or 10,000, something very far from 0. Again, I go to the goal seek. I say I set this one to 0 by changing lambda. This time the machine works like starting from the point 1,000 to find a solution, and you can see it's iterating, and after a few seconds, if you wait, yeah, so This time the solution is 856 point something, and the determinant is minus 0.26. Although this is not absolute zero, but this is almost zero in comparison with the determinant was something 10 power at 14. It was a very big number, wasn't it? So this is practically zero, and I will copy this one 856 something here. As you see, just copy this from the previous sheet, and this is omega 2 or square omega. This is omega, and 2 pi over this is the T2. Again, I emphasize that these two R values are identical to these two coming from manual calculation, but they are both different from the ETABS, as I mentioned before, because the ETABS stiffness matrix is different somehow, but they are very close together. That's it for using Excel to solve this problem. If you're dealing with bigger matrices, it's very easy just to follow this instruction here. You can work with any dimension in your matrix just to calculate the eigenvalue analysis. And this tool is also good for solving other sorts of system of equations if you have any. Thank you for watching this video, and please proceed to the next one.